Hello, student. Just I explain about this X-ray diffraction pattern. So you are looking at this is an X-ray diffraction pattern. This X-ray diffraction pattern is obtained by using this Debey-Scherrer camera. This is a special type of older camera which is invented by Debey-Scherrer. You can see Debey's photo is there. So in this Debey-Scherrer camera, this photographic film is loaded inside this camera. This is a photographic film. So it is loaded onto this camera, and from left side, X-ray beam is sent. X-ray beam is sent, and sample is kept here at the middle of the camera. So at the middle of the camera, the powder sample whose X-ray diffraction is needed is kept at the middle. And what happens? The X-rays enter the camera from left here, fall on the sample, then take the Bragg reflections, and then exits the camera in this direction. Okay. So the X-rays are used for the study of the crystalline solids because of the fact that the wavelength of the X-rays, is comparable to the dimensions of the unit cell. So the crystals are the crystalline solids are having the atomic planes, and two successive atomic planes acts as a slit, and whose width is comparable to the wavelength of the X-rays, and that is why X-rays are the only possibilities to study the crystalline solids. So what happens when the X-rays fall on the sample? X-rays get scattered. Some rays goes in this direction, and some rays gets reflected in the backward direction. And these reflections are called as the forward reflections, and these are called as the backward reflections. So these scattered X-rays hit the photographic film, and accordingly, the circular rings or fringes are formed on the photographic film. So a circular ring represent the condition where the Bragg's law is satisfied. Once the Bragg law is satisfied, a set of rays coming from which are reflected or diffracted from crystal planes undergo the interference phenomena, and hence produce this type of circular fringes, and intensity will be maximum at that condition. So in this way, this effect is also seen here. This phenomena is seen in this photographic film. You can see here entry is that this hole is called as the entry hole. This is called as the exit hole. These are here. This is the entry hole. This is the exit hole. The entry hole means that is the hole where the X-rays enter this camera and falls on the sample. And the exit hole, at the exit hole, X-rays escape out of this camera. So in this way, X-rays are generally used to study the crystalline solids. And look at this X-ray diffraction pattern. What is observed is that you can look here. These rings towards the exit hole are brighter or sharper. We can say brighter or sharper, but these circles, these circular rings at entry side are fainter and slightly broader. So this happens. This happens because of the forward and the backward reflections. On the exit side, these rings are formed because of the forward reflections, and hence the intensity is maximum. But here on entry side, these circular rings are formed due to the backward reflected rays. So this is what happens. Okay. A ring represents the condition where the bracks lie satisfied. One more thing is observed here. You can see doublet, singlet is there. So this pattern is consisting of doublet and singlets. So this clearly shows that this given sample under investigation is a face-centered cubic crystal. Because for the face-centered cubic crystal, the allowed Miller indices are in such a way that doublet, singles are formed continuously. So by looking at the X-ray diffraction pattern clearly, we can judge what kind of sample it is, whether it is simple cubic or body centered or a face centered. So this is just a simple, small explanation about this X-ray diffraction pattern. Thanks.